5.2 day 1, we start off by approximating this area. It's the integral from 0 to 10 of f of x dx. The way we read that is the area under this curve from 0 to 10. So notice I said under, I mean between the curve and the x-axis. So we have what we call the signed area. So it could be positive or negative. Specifically, this is going to be positive area, and so is this. So we're going to add those. And then this area, because it's below the axis, and this area is going to be negative. So we're going to subtract those. Now that I'm ready to approximate, it looks like this is approximately a triangle. So it looks like this is approximately a triangle where its base is 1 and its height is 3. So 1/2 base times height for A1, it seems like that's going to be 1/2 1 times 3. It looks like it's about 3/2. So this is about 3/2. When we look at A sub 2, again, we're just looking for an approximation. I'm going to approximate it with this big old triangle. Again, for A2 looks like it's approximately 1/2 base times height. Its base is 3. Its base is 3, and its height is 1, 2, 3, 4. So it's going to be half of 12, which is 6. But then I'm going to subtract A sub 3. So if I look at A sub 3, that looks like it's got a half. Looks like it's got a half, and this is 1. So I'm going to say that that's approximately 2. But then if we look at A sub 4, to me it looks like it's, I see one triangle and another triangle. So this first triangle piece over here looks like it's half of 2. So that looks like it's going to be about 1. And this triangle looks like it's going to be about a half of 4, so it looks like it's 2. So I think that that's about 3. So that whole thing looks like it's going to be 6 minus 5, which is 1, plus 1.5 is about 2.5 square units. Looks like that would be the area that I approximate. So all they said was approximate. They didn't say over or under. We just got a ballpark. So there's 5A. Now when we look at 17, what it wanted for 17 is if you are given the limit as n goes to infinity of the sum of I equals 1 to n of e to the x sub I over 1 plus x sub I delta x on 0 to 1. So we are summing up in rectangles and then letting that number of rectangles go to infinity. So we know that that is going to be an integral. It tells us on 0 to 1 here. And every rectangle is going to have the width delta x. In the limit, that becomes dx. And then our height here is just the function. So that function is going to be e to the x over 1 plus x. So that would be the integral that we would need to solve for that limit. So that's 17. Then if I look at 19, same sort of thing. For 19, it says I've got the sum I equals 1 to n. So I'm summing up in rectangles. But I have 5 sub xi star. So it's any old n. So they're really making sure you understand it's any point inside that interval. We cube it minus any old point in that interval. 4 minus that. We take that, multiply it by delta x. Then we let the number of our rectangles go to infinity. And they want to do that on 2 to 7. So if this is going to be equal to an integral, I'm going to sum up, this is an elongated S, I'm going to sum up infinitely many rectangles from x equals 2 to x equals 7. In the limit, my delta x becomes dx, and the function that I'm going to integrate here is x cubed minus 4x. So that's another way to write that sum. So that's 19. So now we move on to 34. let's see, that's 19, to 34. Just double check, 17, 19. Let's now do 34. When you're looking at 34, what does it want? So 34 is a picture. Let's go over to the textbook and look at 34. So here's 34 down here. Let me take a picture for you. And let me copy, delete, break, and then boop, boop. Here's 34. Let me crop that for you. So here's the picture. I'm just going to zoom in on the picture so that for the video, YouTube doesn't flag it for copyright, because we're just using a picture, man. So if I want to know what is the integral from 0 to 2 of g of x dx, that just means the area between the axis and the curve. So from 0 to 2 would be here, so the area under the curve would be this. That looks like it's a triangle, so it's 1/2 base times height. In this case, it's 1/2 the base of 2, height of 4, so it's going to be 4 square units. Then it wants to know what is the integral from 2 to 6 of g of x. Go to different color. The integral from 2 to 6 of g of x dx. In this case, it looks like it is a circle with radius 2, so it's going to be pi r squared, specifically pi 2 squared. But notice it's just half of that circle, so it's half of a circle. It's just one hemisphere. So we're going to get 2 pi. That would be the area of this piece right here. Then it wants to know the integral from 0 to 7. So we see that this last little piece right here is just 1/2. So we can say, maybe I'll make it blue. So the integral from 0 to 7 of g of x dx, if we use our properties, is equal to the integral from 0 to 2 of gx dx plus the integral from 2 to 6 of gx dx plus the integral from 6 to 7 of gx dx. So if we add up all those, we have 1/2 for that last piece. We had 2 pi for the middle piece. And then we had, for the first one, we had 4. So if you add up all those, you get 4.5 plus 2 pi, which would be exactly what that area would be. Pretty cool. So that's 34. Then they want us to do 37. Bloop, bloop. So 37. Let's see. So 37. If I have the integral from -3 to 0 of 1 plus the square root of 9 minus x squared dx. So I need to interpret that thing in terms of an area. So if we didn't know, we could go here, and if we look at our old buddy Desmos, I can say I want 1 plus the square root of 9, what is it, minus x squared? And let's see if we can't reason our way to what this thing is. Do you see that if I look at this, it's trying to tell me that I have a circle that's been pushed up. Try that one time. Here, let me crop it the way it needs to be before I paste it. Done. Copy, delete. So just so it's really clear that you can see what's happening, this part right here is a semicircle. So it's centered at 0 with a radius of 3 is what that's really trying to tell you. And then this +1 has just moved that entire graph up. So one way to think of it is if that is the axes, and then here's my graph that looks like this, what we need to do is we need to find the area of that semicircle on top. So it's going to be a hemisphere plus this area right here, plus this. So we can see that it goes, since this is a radius of 3, it goes over here to 3 and over here to 3, -3 to 3. That means this rectangle is a 6 by 1, and then this semicircle has a radius of 3, so it's half. It goes from 1, 2, 3 to 4, so it's got a radius of 3. 1, 2, 1, 2, 3. So if this is equal to half pi times the radius squared. So it's going to be what? 9 pi over 2 plus 6. That's going to be the exact area under this curve from -3 to 3. Notice I found from -3 to 3, right? They just want from -3 to 0. So I just want half of what I just found. So we go back and we say, okay. Notice what I did at the very end. I said, did I answer their stupid question? And I didn't quite do it. I need half of what I get here. And so our answer is going to end up being 9 pi over 4 plus 3. Great work. So that was 37. We're so almost done. We need 39 and then 48. So let's look at 39. So the really cool part about 38 is we were able to interpret an integral that may be pretty difficult to do by hand. When I change the form and see it as an area problem, then I can do it. Because you know a lot of math and science is about form. So 39, it says the integral from -4 to 3 of absolute 1/2 x dx. So what does absolute 1/2 x dx look like? Well, you can first just graph this thing. That's y is equal to 1/2 x. And then the absolute just takes anything that was negative and flips it over the axis. So this is going to be our graph absolute 1/2 x. That's going to be it. And it wants to know from -4 to 3. So it wants to go over here from -4 all the way over to 3, right? So to find all that area. So I guess when I look at it this way, we know that any time in math or science, you should be drawing a picture, and we see how now this answer, if you have a picture, just falls out. So what I've got is I've really got one triangle plus another triangle. So for that first triangle, it's going to be 1/2 base times height. And this one is going to be 1/2 base times height. So its base here is 4. And its height, well, if I take 1/2, absolute 1/2, and I plug in -4, I'm going to get this height right here. So if I do f of -4, I get this, which is what? 2. So this height is going to be 2. Plus 1/2, well, this base over here, maybe I make it blue. This base over here is going to be 3. And then this height, again, is going to be f of 2. Plug in 1/2 absolute of 3. So that's just going to be 3 over 2. So we should end up getting 4 plus 9/4, right? Which is going to be 16 over 4 plus 9, which is 25/4. And that's going to be the area under this absolute value curve. So the main idea there was that to look at absolute values of functions, you just draw the normal function, and then anything that was negative reflects over the axis. So specifically what this line over here is negative 1/2 of an x is what this piece of the graph is over here. If you want to make your absolute value function, which we drew like so. So if that's 39, last one is 48. Let's look at it and be done. So 48. So if I look at 48. So 48 is so this is just using the properties of integrals. So if I know that I want to find this integral, but so I know actually that that's 7.3, but I also know that the integral from 2 to 4 dx is equal to 5.9. It wants us to use that information to find the integral from 4 to 8. Well, we know that you could take the area, imagine that this is our curve. I'm going from 2 to 8. So if I first go from 2 to 8, and then I take away this area from 2 to 4, so I subtract the area from 2 to 4 of f of x dx, what you're going to be left with is just the integral from 4 to 8, which is what they want. 4 to 8 f of x dx. Do you see that if you cut that off, you're left with what they want? Yeah? So, we know they tell us that this is just equal to 7.3, and they tell us that this is just equal to 5.9, and that's your answer, yes? So that was 6. If this was actually 6, this would be 1.3, but we're not taking away 6, so it's 1.4. We're taking off a tenth less. Right? There you go. That's it. Have a good one.